Fredrik Norell joins us for a discussion on thermal imaging for shipboard surveys. We'll talk about how these inspections work, the challenges that thermographers face, and the best practices used by technicians. All that and more coming up next. Hey Fredrik, thanks for joining us. How you been?
Good, great, it's perfect weather. Nice to be here.
Well, it's great to meet you. I'm looking forward to this. Shipboard surveys. I think it's going to be a very exciting topic. Before we get into it, tell us more about where you're from and what your background is in thermal imaging.
Right, so my background is in electrical engineering, and I've been using that as electrical thermographer for the past 3 decades. I'm also the ITC level 3 trainer in Sweden. So I live in Stockholm, Sweden, and I perform mostly electrical inspection on cruising ships.
Well, we're going to talk about that today here. What kind of drew you into this? How did you get into this type of application?
Well, first of all, my background is I was brought up in the sea by my parents. They took vacation all summers. We were out in the sea, mostly sailing, but also motorboat. So, from childhood, always stayed at the sea for like months a year. So that's the sea. It kind of gets to. So once you're there, but it eventually, since I'm back, I did electrothermography on industrial for many years, like 7-8 years industrial thermography, and the questions came up from the cruising ship owner. They simply called me up and say, "Hey, can you do electrical thermography on our cruising ship?" And I said, "Sure, why not? How different can it be? One is on shore and one is floating around. I mean, it's pretty much the same stuff." So that's how it started. They actually phoned me, asked me, they want to do it, and I said, "Sure, we work something out." So.
Well, tell us more about that. The typical shipboard survey. I think we'd had chatted offline about this. It's not your typical type of inspection. You have certain unique challenges working in that environment. Tell us more about the environment and kind of what the situation is that you run into when you do these types of inspections.
Right. So the first thing, when you get aboard, you become part of the crew. Obviously, you meet up with the electrical engineer who is responsible on board, and then you do some sort of major plan. So that's kind of equal to industrial. But then kicks in the differences, and they are severe differences. I mean, first of all, they have very short time on their loadings. For example, bow thrusters, they only run for a few seconds, so you got to be ready, you got to record it, and they shoot like 2,000-3,000 amps in just very, very short time, so you really need to be ready. And there's also the thing that they're actually moving. I mean, they're floating out to sea, and there's stormy weather, there's really bad weather, there's raining, and the whole ship is going back and forth. So if you're into seasick, you should probably not be doing the electrothermography on cruising ships, because even if it's slowly rolling around at the sea, that really kicks in the seasickness in many people. So moving around, and there's a lot of challenges. If it's bad weather, you need to have every gear strapped into your body. You cannot have anything in your hand.
So we have an example of that, Fredrik. You sent me a picture, I think, right? Is this a typical setup, what we see here?
It's very, very typical. We need everything strapped in, tight to your body, because we need to have both feet and hands free. Because you're climbing upside, downside, and going upside down even sometimes. So it's very, very challenging. Some of the manholes you have to get into can be very, very narrow. So you need to have your all hands completely free. So even once you have found the cabinet you're supposed to do inspection on, you have to strap in, make sure you have something hard to grip in. Then you can remove your camera, do your inspection, holster it again. So we only use holsters on our body. It could be in different places on the body, but any kind of equipment needs to be strapped in. Cannot be hanging around or fall out or anything. That could become very, very dangerous. So it's a safety issue. They do have problems with vibration going around on the ship. The vibration is changing. can be quite severe sometimes, depending on the RPM of the main engines. It's very hot in the machinery. It's about 50 degrees Celsius. I don't know how much that is Fahrenheit, but
About 120 Fahrenheit,
yeah,
just over 120. That's hot. Yeah.
it's pretty hot. It means that when you're working and you need full protective gear, even arms fully covered, because you can get burned on a lot of steam. They have steam systems on board, and the air leakage, steam leakage are very high energy, and you can get severely burned. And they have rotating machinery that could pull an arm off if you get too close. So don't do that. And the electrical cabinets are mostly open. They're completely open. They have no covers on the backside. So don't fall in because you get electrocuted. and and so on. So there's a lot of things that can actually be very, very dangerous on these ships. So you need to be aware on where you are and what you're holding and where you're going, and stay focused all the time. As soon as you get tired, you need to take a break. Because that when bad thing happen, you get tired, you get sloppy, and then you tend to break the rules a little bit.
Well,
Uh,
how many days are you typically out at sea? Like, how long is one of your inspections, your deployments here on a ship?
3 days at a time normally, and we work about 16 hours a day. Then we have about 8 hours of sleep, and then we continue. So yeah, so it's quite long days. We do have freely breaks, of course, for lunch and at our disposal. So it's not that we have to be working 16 hours. But that's the shift time, and they allow us to decide how many hours and how many breaks we need, and if we need 2 lunches, then we are free to do 2 lunches. So yeah. I actually even brought my son with me on one of these trips. I brought him with me when he was in high school, because I wanted him to stay in school. So I said, it's either this work, and it's really hard. It's three days, and anything can kill you here. So, and after that, it turned out well. He went to college, so he's going for his second master degree right now. So that might have maybe, put something in his mind that, it's either this work or you go to college. So, yeah.
Well, congratulations. That's great to hear. Is he thinking of going, sort of following in his father's footsteps, perhaps getting into thermography, or is he looking at something else?
No, he's becoming a lawyer now. So
Oh,
it's completely different.
that's great.
So yeah, but there's also a lot of other challenges. We have restricted access to some parts on the ship. We're not allowed to be there. Rudder machinery, for example, you're just not allowed to be in rudder machinery, because if you open bronc cabinet or maneuver anything that you're not allowed to, you can even stop everything from working, and the whole ship can, run up on the shore, and that's not a good idea. That would be a bad day at work, as we say. So yeah, and so that's also very challenging, and they also have redundant systems on everything, and they don't change pumps unless they're tied up in a harbor. They don't do that, even if they can do that, obviously. But it's the risk management thing. If you go to electrical engineer on board and ask him, can you switch these pumps, whatever oil pumps or anything, and he's just gonna say nope. Because if I switch them, maybe they don't start, and then maybe the other one won't come back online, and I have to take down one main engine, and that's gonna have to make me call the captain. He's not gonna be happy about that, so we don't do that. So
Yeah,
no,
it kind of brings in an interesting perspective on downtime, or unplanned downtime, I guess, is what you want to try to avoid. Not having a ship, not having power at sea is not a good situation to be in. I understand that at least, but
it is a severe problem if that it still that happen, even though they are so precautious. And they do have 4 main engines. Normally they do have 4 main engines, and 2 of them are up and running always. And the third is the backup engine. If any one of the first or the second fail, the third one is ready to kick in and make sure, even if it's a bad weather or storm or anything, that there's no dangerous situation. And the fourth one is normally regularly on service. So that's the one they do the oil change and prepping it to become the next backup engine. So it's a circulating scheme. They always have their engines ready, up and ready. So.
just a quick reminder, if you have any questions or thoughts about today's topic, be sure to leave a comment you want, contact us directly. Feel free to reach out to the Infrared Training Center. Call us at 1-866-872-4647 or send us an email at info@infraredtraining.com. All right, Fredrik, let's take a closer look at the inspection environment, some of the systems and components that you're looking at. Before we get into those examples, I'll bring those up here in a moment. You had mentioned the vibration earlier, and you showed me some video of this. I want to share this with our viewers. How big of an impact is this vibration, is this environment having on the health of these systems on these ships?
The vibration is a severe problem. The continuous vibration that's over time, day by day, hour by hour, and week by week, year by year. And those cruising ships that I go on to, they go 24/7, and they go every day, all year round. So this vibration is a severe problem. It makes the joints on all connections come loose over time. Not all of them, but some of them.
Now, you'd sent me some examples here of some of the more typical things that you're looking at. I'm going to call a couple of these up, Fredrik, and we'll just kind of go through these and take them one at a time. This first one here looks like some bus work. Do you specifically remember what was going on here? What did you find in this situation?
This is a very specific fault, and you could believe that maybe it has to do something with the bus bar, but that's not the issue here. The issue is the magnetic field are heating up the bolts between them. And if they get too hot, they can damage all the settings all around it. The holders, the isolators that actually keeps them apart could get so hot that they get destroyed, and eventually you will have a shortcut. So induction is a very common problem on cruising ships. They have very high current, high magnetic field, and unfortunately they use sometimes magnetic bolts. They should not use that. Stainless steel or non-magnetic material has to be used. This is actually also induction, and you can see here some power cables going alongside, and you can see it's a lot of them. Maybe it's like 10, 12, 13. It's a dozen of power cables, and it's running hundreds of amps, so totally thousands of amps, and they're all one phases, so they produce a very strong magnetic field. As you can see, there's a iron rod placed very, very close to the cables, and it has nothing to do with the circuit or anything. It's just there to maintain everything in position. So it kind of works like an insulator, but unfortunately they shows magnetic material. So what we're seeing here is an induction. Very high current produces a very high magnetic field, and it's heating up this iron bar because that's magnetic. And you can, if you look closely, you can even see that the cables, at least the cables who are against the metal rod, it's actually damaged. So it melted. So this can get so hot, so it melts the cable. It already had melted the cable a few millimeters in. And if this continue, eventually this iron rod will get so warm and melt all the way into the circuit, and then you will have an arc flash. And I've seen this actually on other ships where this have happened, and it becomes an arc flash, and it means it will blast out that whole cabinet. There's nothing gonna be left there. If someone's there, they're gonna die. So when I see this, I take my image and I move out of there, because this could happen, within an hour, probably months before something happens. But you never know. It could happen earlier than that.
This next one looks like we have a fuse that you caught.
Yep. So also the fuses, the melting fuses, they also have connection inside the cabinet, and could be some tricky to see the location. We don't actually see the faulty area here because that deeper inside the cabinet. But we know that, for example, a fuse should not be 150 degrees Celsius, because that's way overheating. So there must be a problem inside here. It has to be replaced, and probably need to replace cable or termination and so on also.
Yeah. Well, speaking of heating up, these are getting progressively warmer as we go through. This one kind of caught my eye, about 127 degrees Celsius. Where did you find this?
We see this regularly. So this is also a breaker, high consumption breaker. So it's in the main switchgear on board. So this is on the back side. They normally have open backside on the switchgears. In industrial, we have covers on both sides, but in ships, they don't have that. They only have covers on the front. So when you walk around the switchgear, it's completely open backside. So it's very easy to inspect, but it's also very bad if you fall into it because it's completely open. So make sure you're strapped in and choose a good weather. And it seems like be a crimping or a bad connection in one of the breakers there. And these temperatures are very common. We find these temperatures every time we go on board and do inspection on ships. It's normally very high temperature, and visually we normally see damages. So it's very severe problem.
Yeah. This one here, about similar temperatures. What was this powering? What did you find here?
So this is a little bit lower in temperature and so on. It's not that damaged, but still it's very severe temperature, and you can see that the color on the marketing have become a little bit dim, a little bit darker. So I would guess this has been going on for a few weeks at least. And I think this was powering the radar system on board, navigation supply. So if they lose this, they will lose the radar navigation. And if it's bad weather or mist outside, that could have a severe consequences. They could miss another ship or something like that. And yeah, so this is also a very common problem we find. We find hundreds of these problems every time.
Got another one here. It's just a fuse. What about this? Tell us some background on this.
Yeah, this is also a very high risky problem with what we call categorize 1. That's the most severe problem. So it's very, very high temperature here. Fortunately, the porcelain or the knife fuse can withstand this temperature, so it's not going to burn at the moment. But the temperature is by conduction also going to the cable. So the cable and the cable shoe are probably destroyed. It has to be replaced. I don't remember what this go to. I think it's for the ventilation room. So this would be very top of the ship. So this would be for the ventilation. They have about 9 ventilation rooms for different parts from the ship. So this is a very important component because if they lose this, they lose the AC and ventilation on board. And if you have 2,000 passengers, that's going to heat up quite fast. Not going to be very comfortable on board. I've seen other cruising ships. There are stories on TV you can read about. They have a malfunction, the switchgear. They have an arc flash. It goes down. I think we had a ship like 10 years ago, so they have no toilets on board for a week or something, and going into the Caribbean. So not funny. Not funny. So
No.
So you never know what kind of problem it can cause. This would probably just cause the ship to get hot. I believe this is for the AC system. But it's a knife fuse, and it's very, very hot, and it's very important to attend this problem as soon as possible. So this would be like within a day. Within a day, this problem has to be taken care of.
Well, Fredrik, I saved the best one for last here. This was this. I can't believe this one. Are we really looking? Is that number right? We're looking over 800 Celsius. What was this one?
Yeah, this was for the bolt for the healing pumps. So the healing pumps are used to stabilize the ship in storms, and if containers are moving around or anything happens, it's also used in harbors when letting trucks and cargo on and off. So what looking at is a cable shoe where the bolting has gotten so bad that the resistance is so high that you can actually see it glowing in the visual spectrum. So in the right optical image, you can see it's glowing because it's melting.
Not a laser pointer, right? You said that is actual giving off visible light there.
Right, it's giving off visible light because it's welding together. So the bolts and nut and the joint are welding together in front of me. So it was about 1,000 degrees Celsius hot. So I told them, cut it off, cut it off, cut it off. You don't need to run it anymore. And it took me a few seconds to adjust the camera. I needed a higher range in the camera, and when I finally took the image, it has cooled down to 800 degrees Celsius. So that was cooling down to 800. And this happened every time they were using this healing pump. They're only used very short time. As mentioned before, in ship, they only use the equipment for a very, very short time. It's a 500-600 amps of burst, maybe 10 seconds. Because they're moving water from one tank to another tank, ballast tanks. They don't use it so much. Because when you see the temperature is that high, you can wonder, how can this be working? I mean, why doesn't it just blow up? Because they use it in such short time that every time they use it, it just welds a little bit together and starts to melt. Then they turn it off in 10 seconds and it cools down. And you can see in the visual that its damages are severe. And this was such a severe damage that I said, you have to stop this immediately. You can't use this.
If you're enjoying today's conversation, be sure to get social with the Infrared Training Center. You can follow us on X, Facebook, Instagram, and LinkedIn for helpful tips, thermal imaging best practices, and much more. And stay tuned until the end for details on infrared training and special offers that might be available for thermographers. All right, Fredrik, finally we have some examples from a recent inspection that you did. Can you tell us or provide a little bit of background of where you were and what you were looking at?
Right, so this is another cruising ship. It's about 2,000 passengers. And what we're looking at is the main switchboard. One of the cabinets, and this specific cabinet is for all the AC units. So this is for ventilation and air conditioning on board. And we can see that one of the faces clearly show a very high temperature or a very, very high anomaly compared to the others. The temperature is not that high that things starts melting or so, but it's clearly a very high anomaly on one of the faces. And we have one problem here. One of the problems is that we have a cover. And if you look closer, you can see that there is a cover in front of the joint. So we don't get the perfect view here. And no one wants to remove the covers because it's too close to the bus bars. It's like millimeters there. And since this cruise is going on at the moment, the captain rarely gives us permission to remove covers more than absolute necessary. Because if we drop a bolt or a nut or a tool or anything, we can have an arc flash and perhaps even more problem on board. Maybe he loses the steering or engine or anything. So this is a severe problem. It's a breaker, and it's a very high loaded breaker. It was about 200 amps on each face, and I can clearly see that one of the faces clearly shows a high anomaly. So my suggestion was that they should replace this breaker at the earliest convenience, and that's what they did also. They replaced the whole breaker.
You know, that really puts it into perspective, because I was going to ask you that. You know, we talk about the potential cost of failure. In industry, we discuss downtime all the time, you know, trying to avoid downtime. And in your case here, the consequences seem a lot higher potentially, right? We're talking about a cruise ship, a commercial cruise line with passengers. And you said that if this were to go down, potentially it impacts steering. I mean, that to me is it just brings a whole new perspective on, you know, prioritization and criticality that I just don't think a lot of people in industry really appreciate.
Right. Yeah, we have to take that in consideration as well. You know, risk management, assessing risks. And I would bet airline captain do the same. You know, do we have to fix it here, or, you know, if we fix that, maybe we could have other problems, and we don't do that. And the same for a captain. He, on a cruising ship, he has the responsible of thousands, maybe tens of thousands of passengers. So he want to make sure that you don't have any more issues with anything. So if it can wait, they prefer to do all the repair in harbor. If it can wait. Sometimes it can't wait. You know, if you can't wait, you can't wait. But then we try to, you know, as little disruption as possible. Yeah.
Well, how about this next example here from your recent inspection? What was going on here?
Yeah, this is the lightning board. So this is for the lighting around the cruising ship. We start all the way from the machinery, main engine and generators and main switchboard, and then we move along the ship all through ventilation. And this is the electrical board for lightning board. And it's kind of hard to find this problem because you can see that all the cables are going hiding each other. So the problem here was that one of the joints, perhaps by vibration, is loosening up, so it's high resistance, and you can clearly see the thermal pattern, and you can clearly see the difference in temperature, but it can be a problem to find it because there are other cables in front of it that covers it up a little bit. So I would say it shows that you have to move around with your camera, not just take one angle, move around, see from different angles, make sure that a problem is not covered by anything else, and be careful. Don't do it too fast. Take your time.
And then we had one more example from a recent inspection. What was the story in this situation?
Yeah, so this is also a breaker, but the amazing thing about this one is that if you look at the temperature, the thermal imaging, it doesn't look that severe. The temperature is not that high and the difference not that big. When I show this thermal image to others, they say, you just could have let that be, you don't have to do anything about it. But then I show them the digital image. And the digital image clearly shows that the first phase is clearly burned. It's heavily burned. And you can see that also not only the insulation is damaged, but also the copper is damaged. So it's completely damaged. It has to be replaced. Both the breaker and the cables and everything has to be replaced immediately. This is a very severe problem. The reason that we don't see it that much, you still see it, but not so much in the infrared, because it was very little loading at the moment. Because that changes over time. Not all the equipment have the same loading all the time. And I think this was for a compressor, so this was for air pressure. So the load was very little because they didn't have much need for air pressure at the moment. But once in a while they need more air pressure, and this kicks in much more loading, and then you will have much higher temperature.
Well, it's a fascinating application. Fredrik, really, thank you very much. You brought some great examples here today. Pretty impressive finds. Some of these anomalies approaching 1,000 degrees Celsius. I've learned a lot, and I think everyone watching here has learned a lot. I really appreciate your time, Fredrik. Thank you.
Thank you. Happy to be here.
Remember, if you have any questions on today's topic, please feel free to reach out to the Infrared Training Center directly. Call us at 1-866-872-4647 or reach us via email at info@infraredtraining.com. Our website is where you'll also find other free tutorials on a variety of topics and our complete training schedule. Plus, we also run a number of special training offers throughout the year. To learn more, give us a call or visit the Infrared Training Center online at infraredtraining.com. Thanks again for watching, and we'll see you online again soon.